Good afternoon, chemists. Welcome to week 3. It looks like you guys are having a fabulous week, very busy week 3. Some of us are taking tests and then having to pop from e-session to e-session. Yes, Emily, we are all excited and want to know how your ice skating went. That was going to be, Sam beat me to it. Oh no, Emily. Is your back doing better now? Oh no. Well, we hope you find something that will help your back. So maybe like chiropractor or some physical therapy, maybe. That's just stinky when you are training for something so hard and then you get hurt. That is very difficult for athletes to just sit at the sidelines and not be able to do what they need to do. Well, we wish you a speedy recovery and hope that by next week you're telling us that your back is feeling better. So, super cold outside. One of the coldest weeks of the year, or the season so far, the winter season. What is your favorite hot beverage? I love some good chai tea lattes. I also super love some hot chocolate. It is February, so we are in the heat, the thick of the winter here. We only really have um, about 6 more weeks, and then we get the first day of spring. I'm not a big coffee person, but I do like like a hot chai tea for sure, hot cocoa, and yes, teas are delicious. Chamomile is great. I like a good black tea as well with some honey in it. Right. I do love chai tea so much. I probably after this e-session will make some chai tea for myself at home here too, because it's so cold out. We learned last week that the reactions and how to predict reactions, like the products of those reactions. And as promised, this week we are going to do the same thing, but then we're going to be balancing equations as well. So a lot of you last week brought up like, hey, what happened to that extra hydrogen, or what happened to that extra zinc, or what it might be in there, like why is there 2 on one side but not on the other side when we made the product. And so as promised, we are going to learn that today. I'm going to go through what our lessons are, and then we will go and do practice problems on balancing equations. So this week we are in the balancing equations. Our ICANS is to use vocabulary words associated with balancing equations, so really getting familiar with coefficients and subscripts and how those two things are different, and then I can balance equations. I do have a how-to balance equations. If you click here, there's a note sheet with some directions on how to do it. I also have me actually going through and doing the balancing equations. I gave you Khan Academy has some practicing. I would get your notebook out, turn it to page 32, click on the link, and continue to practice as much as you need to with balancing equations. When you are practicing this and you are learning how to do it, it is a really good idea to continually try and figure out what it is that you're doing really well and what is it that is like a little bit off, or something that you're just not really fully understanding, and that's where some of the really great questions then would come in. Yes, you do. No, 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 no. I think I gave you the full equation and you just are balancing. Next week, you'll have to put all of that together. And then you do have a summative balancing equations T3. You do get 2 attempts on this. If you do not do what you would like to do on those 2 attempts, then you'll need to ask Mr. Wozniak or I for a 3rd attempt. And to do that, you would click here. You'd show us pictures of your notes, pictures of your practice, and that would then initiate for us to get started on a 3rd attempt. So that's what's going on in week 3. Are there any clarifying questions? Sam just had one, but are there any other clarifying questions about the work this week? I'm just giving a little bit of wait time in case you'd have any clarifying questions. All right. So at this time, if you feel like you are, feeling pretty good about balancing equations or doing the work on your own, then you are more than welcome to leave the e-session. If you would like to stay and do practice problems with me on balancing equations, I'm asking for you to grab your notebook and open it to page 32, and then give me a thumbs up when you are ready to go. All right, this is awesome. I'm so glad that you guys are deciding to stay. So balancing equations really is a chemist's way of showing how matter is not created nor is destroyed when a chemical reaction takes place. Matter just doesn't go somewhere. It has to be retransformed into something else. It may leave the equation in a gas, or it might rearrange itself to look differently because this reaction took place. However, we do need to show that in this reaction that our matter was not created and it wasn't destroyed, just simply rearranged. So that is where balancing equations come into play. I'm going to put one up here, an example that we'll just start with. So I'm going to just go in blue. Now, I will not have you predicting just yet. That will be next week. And I am going to just put like a line in front of our compounds so that we know that we might be putting numbers there as we balance. As I'm writing this equation, can you tell me what type of equation is this? Is this single replacement? Is this synthesis? Double replacement? Combustion? What type of equation is this? What type of reaction took place? Now I forgot to leave space for my numbers here. Oop. Awesome, Tristan. Yep, this is a double replacement reaction. So what is happening here is this sodium is trading places with this lead, and we are creating two new compounds on the other side. And so what we are doing is now we're just going to be counting. And so I'm going to put a line right here because this is my reactants over here. Here are my products over here. And so we are going to be looking at the reactant side and on the product side. So on the reactant side, I have sodium, Na. And then I'm going to keep NO3, which is a polyatomic ion. I'm going to act like it is an element itself. I have lead, Pb, and I have oxygen. And I'm simply just going to say, like, how many of these things do I have on this side? So I have one sodium here. I have one NO3. I have one Pb, and I have one O. All right, so what I have on one side, I do have on the other. So I am going to just write my list again. Okay, so I'm going to look over here. I have two of those. Now, that 2, I am looking at this subscript right here. This 2 is only for this sodium right here. So I have 2 sodiums. Again, I have a subscript right here. This 2 is talking about this element or this polyatomic ion. So I have 2 of those. I don't have any subscripts here, so I only have 1. And I don't have any subscripts here, so I only have 1. All right, and so now what I'm looking to do is I notice that I have 1 sodium on this side but 2 on this side. So I need to make sure that these 2 sodiums are balanced. So I'm going to ask myself what times 1 is going to equal 2. Hopefully you can see that, 2 times 1 equals 2. So this number 2 here is now going to go right in front of this compound. Now this right here is called a coefficient, all right? And we're going to really have to think about this coefficient. We're going to utilize our algebra knowledge. I know that might scare some of you, but this 2 is going to get distributed to every single element in this compound. So just like we have these subscripts right here, which are only for that specific element, when we use a coefficient and we put a large number in front, that number goes to every element in that compound, okay? And so not only does that tell me that I have 2 sodiums, 2 NAs, but it also is going to go for the polyatomic ion NO3. So now I only had 1 of those. So now I have 2 of those as well. Okay, so by putting that 2 there, I then have 2 sodiums. I have 2 NO3s. On this side, I have 2 sodiums, 2 NO3s. And I still have 1 and 1, 1 and 1. And so in essence, now this equation is now balanced. I'm going to pause for 1 second, and not 1 second, a couple of seconds. You will not hear my voice, and I simply want you to ask any questions that you feel are confusing to you about this process. Okay, so Tristan is confused in general. Okay, so in order for us to understand where your confusion comes in, what part is confusing? So let's just take this step by step. So are you confused as to how to figure out how many you have on the reactant side and how many you have on the product side? Does that confuse any of you? So that part is confusing to you guys. So let's start. Are we okay if we start, if I do another example, or do you want to do the same one? We'll just go step by step. All right. All right, here we go. Let's get, oh, I want to do this. Let's get a new one. Let me grab a new one. I'm just trying to see if I can find one that is, okay, we'll do this one. Ah, you didn't see that. I started balancing it myself. Can you guys tell me what type of reaction this is? All right, we got single displacement or double displacement. Somebody else want to weigh in? All right, so it is a single displacement, and the reason it is a single displacement is because we have one single element by itself, and then we have a compound. To be double displacement would mean that we would have double compounds. We'd have a compound and a compound, but we don't. We have a single element, and then we have a compound, and you can see that Fe took over Ag's spot over here. So now we have Fe is in a compound and Ag is by itself. So Tristan is on the ball here with telling us what type of compound or what type of reactions that we've got. So that's awesome. Okay, so step one is I'm just gonna make my little line right here, okay? So I have my reactant side is over here, my product side is over here, all right? So let's list the elements that we have. We have Fe, we have Ag, And remember our polyatomic ions, we're going to just utilize them as if they were just an element by themselves. So I'm going to list the same thing over here. No. It does not. This process is the same regardless. I just want you guys to continually recognize what type of equation that you have, because next week you are going to have to put all this together with recognizing the type of equation, giving me a products right, and then balancing. Okay, so the step one is how many or how much of the element do we have on the reactant side and how many do we have on the product side. Okay, so let's start with Fe. Fe is right here. Fe is right here. How many Fe's do I have on the reactant side? Put your number in the chat and we'll roll. Perfect. So we've got 1. So I'm going to put the number 1 here, okay? If I go to the product side, how many Fe's do I have on the product side? Okay, so the number is not 2, Tristan. The number is 1. And I can see why you would put 2 with a question mark there. So let's clear up that part of that confusion. So you see that this is a number 2 right here, right? This number 2 only is for NO3. It does not have anything to do with Fe. Does that make sense? Okay. So if I were to ask you on the product side, how many NO3s do we have? How many do we have? 2. Perfect. Then we'll do NO3 over here too. So on the reactant side, how many NO3s do I have on the reactant side? And here is NO3. Great. Yep, I only have 1. How many AGs do I have on the reactant side? Right, I have 1 AG. And how many AGs do I have on this side? Jessica, I'll get to your question in a second. How many AGs do I have on the product side? Okay, perfect. All right, so I'm not understanding where you said, wait, how is it 2? What are you talking about? NO3? Why is NO3 2? Okay. So I'm just going to do a sidebar over here, okay? Just like in algebra, so I have NO3 written like this. This number 2 right here, this subscript, tells me that I have 2 of these. So it's telling me that I have NO3 and NO3. That's what this 2 tells me, and it's being distributed to these. Does that make sense, Jessica? Okay. All right, so step number 1 is we figured out how many of each element we have on the reactant side and how many of each element we have on the product side. Step 2 is to identify where something is not balanced. So where do we need to start? What's not balanced? What is not the same? Correct. So NO3, I'm just going to put this little nodule right here. NO3 is not the same. We have only 1 on the reactant side, but we have 2 on the product side. So we have to balance that and make that so that they are the same. Where am I going to add my coefficient? Would I add a coefficient to the reactant side, or would I add it to the product side? Awesome. You guys got that part down. Awesome. So step 2 is you figured out where it's imbalanced, and you figured out that we have to work on the reactant side. So how am I going to get NO3 to equal 2? What would I multiply 1 by? Perfect. So I'm going to multiply this by 2, and that should give me 2, correct? So this is the next step, is that number 2 now becomes my coefficient. And we write the coefficient in front of the compound that has that element in it. I'm going to say that again. We write the coefficient, so this large number 2, in front of the compound in which it is. Okay, so Tristan, you're there. You're half right. So I want to point out to you that this is the part that gets a little bit like you have to think algebra. Okay, so now this 2 is going to also go to the AG as well, and then it also gets distributed to the NO3. So I have, 1 times 2 is 2, so now I have 2 NO3s, but what do I also have 2 of now? I also have 2 AGs. Okay, so I had to times this by 2, and that gives me 2. Is there another imbalance in this equation? Yes. So by balancing, sometimes you throw another element out of whack as well. And so hopefully you see that now AG is going to be imbalanced. So where am I going to have to add a coefficient? Is it going to be on the reactant side for AG, or is it going to be on the product side for AG? On the product side, perfect. So what times 1 is going to give me 2? And Tristan was a little bit ahead of us, absolutely, so we get 2. So now this 2 becomes my coefficient. And my coefficient is going to go in front of the element, or where that element is, whether it's by itself or in a compound. In this case, it's by itself. So now this gets distributed to AG, so now I have 2 AGs. Is our equation balanced? Perfect. It is balanced, right? Because I didn't change anything with FE. And so I still have 1 and 1. I have 2 and 2. I have 2 and 2. So now my balanced equation, I'm just going to draw a line right here. So when I write this out, my balanced equation would be FE plus 2 AG NO3 FE NO3, the 2, plus 2 AG. This is my balanced equation. After doing that one, did some of the confusion become less confusing? Is there something that's still glaringly like I do not get? Okay. Would you like to try an example on your own, and then we'll walk our way through it to see if you do in fact get the correct answer? All right, perfect. Am I good to clear? I do want you guys to realize that the more you balance equations, like the better you're going to get at it, and then you probably will have, you can start to not have to do this process, right, like that we're doing of writing underneath. So keep in mind, like the more you do this, the faster you get at it, and you don't and you'll be able to do it in a quicker manner. All right, here we go. Let me grab another example for us. All right. All right. First of all, before we start balancing this, tell me, what type of equation is this? Awesome, Tristan. You really know those very well. It is a double displacement. We have two compounds together. Anytime you have two compounds together, you're going to have those things switch and get two new compounds. Perfect. Okay. I am going to put 1 minute and let's go 1 minute and 13 seconds, since my daughter turns 17 on the 13th of this month. And after that, I'll start working through it, and you can see how you guys did. All right, on your mark, get set, go. All right. Are you guys okay if I start going through this, or do you need a little extra time? Okay, let's start going through it. So I will draw my line. Remember, this is my reactants. These are my products. We've got AG, BR, Ga, and PO4. And I have the same on this side. All right. How many AGs do I have on the reactant side? What'd you guys put? Perfect. I have 1 on this side. What about the product side? Perfect. 3 it is. This 3 right here, that's called the subscript, only goes to AG. Okay, it has nothing to do with PO4. It's only AG. So I have 3 of them. What about BR on this side? Yep, I've got 1. What about on this side? Yep, I've got 3. Here's another subscript. That 3 only goes to BR. What about GA? Reactant side, 1. Product side, 1. PO4, hopefully you said 1. PO4, hopefully you said 1. Perfect. Now, where are my imbalances? AG and BR. So let's see. AG, what times 1 is going to give me 3. So hopefully you saw that it would be 3. So that equals 3. And this now is my coefficient. So this 3 is going to go in front. Now that is getting distributed to the AG. It also will get distributed to BR. So that makes this to being 3. So that my coefficient there. So now I have 3 and 3, 3 and 3, 1 and 1, 1 and 1. So my balanced equation
Okay, so it doesn't look like she is reconnecting. I'm guessing either her computer died or internet died. If she does come back, we'll continue, but does anyone have any questions about balancing? Or do we want to do another problem? Because I'm unsure if she was wanting to do another one or if that was it. Make sense? If anyone has any questions, I can answer them too. And like Miss Wells said, the more you do these, the easier it is. Oh, it looks like she's joining back now.
All right, I'm so sorry. Can you guys hear me now? I got kicked out and I had to restart my computer. Okay. I'm so sorry about that. So I was just really ending with the fact that I don't know if you guys saw me starting to write this out, but our balanced equation then is, and how did you guys do? Do you guys feel like you had it right? Okay. Okay. So do you guys feel confident about going on with the work this week? All right, perfect. Again, I super apologize that I got kicked out. I'm not really sure what happened. Okay, perfect. I'm so glad that we got through all the confusion. Mr. Wozniak and I are wishing you guys the very best week. Stay warm. Please contact us if you guys are having issues. I would encourage you to continue practicing with the Khan Academy. And we'll see you guys next week. Have a great one. Bye.